All right, so here we are on the equations and functions assignment. And this is really kind of a review of functions and equations. So we'll get started here with number 1. What is the equation of the line that passes through the point 6, 0 and has a slope of -5/6? Okay. Now to actually render the equation in slope intercept form, y equals mx plus b, we have to use the intermediate form point slope. And here's what that looks like. The thing that I strongly recommend is that you label this point here x1, and then label the y value y1. And then underneath the -5/6, put an m. So you know when you look at the formula I'm about to write that you know exactly what numbers you're going to use. So here's the point slope formula. And as the name implies, it creates an equation of a line given a point and a slope. And some people call it a formula and some people call it a form. I'm actually more likely to call it a form. And that form is y minus y1 okay, so there's that y1 value, equals x, open parentheses, x minus x1. And when I wrote x, I meant to say m. This is the slope, m. All right, so you have y minus y1 equals m, x minus x1. Okay, so you're going to plug in all your values now and create this form. Okay, and when we simplify that form, it'll simplify into slope-intercept form. So let's write y minus 0, because y1 is 0, equals, and then m is -5/6, so we put -5/6, open parentheses, and then x minus x1, and x1 is 6, so x minus 6. Okay, so because this is -0, we can just drop it and just put y equals. And now we have to distribute the -5/6. That has to be distributed to both the terms in this parenthetical binomial here. Okay, so -5/6 times x is simply -5/6x. And then if I think about what you're doing here, you're multiplying -6 in the denominator times -6 in the numerator, so they'll cancel, and you'll just be left with +5. So let me show that in side work so that's clear what is happening. So you can see why this is a neat problem. So you have -5/6, and you were going to distribute and multiply that to -6/1. So times -6/1. And remember how I'm always telling you that negative symbol doesn't necessarily go with the numerator or denominator. It just goes with the fraction as a whole. But let's put it with the denominator to prove a point. Now I can just cancel, right? Leaving me with nothing but a positive 5 over 1 or plus 5. So that allows me to say plus 5. And that is the answer because it's an mx plus b form. Y equals mx plus b. So in this case, the slope m was given to us as negative 5 over 6. And b, the y-intercept, is equal to 5, okay? And just so you know, the coordinates of that position would be 0, 5. Okay, so I like to draw like a graph, a quick graph, not a fancy graph. So let's see, I'm going to need to start at 5 and then go down. Okay, so what I'll do is just say, okay, I've got to start at 5. 1, 2, 3, 4, 5. There's 5. Okay, and then my slope is down 5, 6 to the right. So 1, 2, 3, 4, 5, 6. Okay, so something like this is what the line would look like. Interestingly enough, we get the y-intercept at 0, 5. And because of the way the problem worked out, we actually get, so this is the y-end. For free, we get the x-end, which you usually have to solve for. And the x-intercept, which is actually the solution to the problem, or the root of the problem, is 0, 6. Or pardon me, backwards, 6, 0. And of course, I didn't label the axes, but this is x horizontally and then y vertically. And that's what it would look like graphed. Okay. Moving on to number 2. What is the equation of the line that passes through the point 4, 1 has a slope of 1/2? Once again, we're going to use the point slope form, which is y minus y1 equals m open parentheses x minus x1 close parentheses. And we need to label our points. So this is x1, y1, and m. Okay, so it's time to plug and chug, as they say. So we have y minus 1 is equal to 1/2 open parentheses x minus x1, which is 4. Okay, so when we distribute multiply this, we'll leave the left side alone, y minus 1. And just because this equation is getting a little long, go ahead and draw this to keep our equal signs lined up. Y minus 1 equals negative 1/2 distributed through the parenthetical expression. So you have 1/2 multiplied by x and 1/2 multiplied by -4. Well, 1/2 by x is just 1/2 x. And then you're basically dividing -4 by 2, so that's just -2 minus 2. Okay, one final step, plus 1 on both sides to get rid of this 1 over here. Now when you're adding 1 to a negative number, like -2, you're all subtracting, right? So now it's -1. So y equals 1/2 x minus 1. So we've got the y-intercept at -1 and a 1/2, 1/2 growth rate. The quick graph for this we'd have -1 right here, and then we go up 1 over 2. Okay, so up 1 over 1, 2. Okay. So there's 2 points. This is the y-intercept here, and that point is at 0, -1. And just like the last problem, we get the x-intercept for free. It's at 2, 0, which is cool. And that's the x-intercept, or the root of the equation 2. Okay, so we're going to connect these dots. And that's what our line would look like. This would be the y-axis and the x-axis. All right, moving on to, I see I haven't been putting things in boxes, sorry. So the thing you want to put in a box on this first problem is this here. And then the second problem, this. Okay. Now in the third problem, they just give you a line and say write the equation of the line in slope-intercept form. Well, all you really need to graph a line are 2 known points. For example, I see that I have these marks in the background where they cross, these little graph lines. Those where they cross, they're called lattice points. It's LATTICE points. Okay, lattice points. So, for example, right here is not a lattice point because the line is between 2 boxes. But here's a lattice point, here's a lattice point, here's a lattice point. And so you kind of look at it and you think, all right, what's the slope? It's rise over run. So rise 1, run 2. So the slope, m, you can already answer. M is 1 over 2. And what's the y-intercept? 0, 6. Okay. So B, which is the y-intercept, is 6. Now with just that information, we can write an equation in slope-intercept form. Okay. I just need the slope and the y-intercept. Right. So now I can write down here in the form y equals mx plus b I can write y equals 1/2 x plus 6. And that's it. And just in case it wasn't exactly clear how I came up with that slope of 1/2, I found a point which I knew was in this gray grid pattern here on a lattice point. So on the y-axis at a lattice point where it's crossing. And so then I just moved up 1. So I know that my numerator is 1, positive 1. And then over 1, 2. And I'm back on the line. So that's where I got up 1. So rise 1, and then run 2. Okay. So you put the 1/2. That's how you got that slope. All right. We are now moving on to number 4. And same type of question, write the equation of the line. And the way we're going to get the answer is in a very similar manner. So again, I see that the y-intercept is at a lattice point, which is good, 0, 2. And it's a negative slope, so instead of rise over run for slope, it's more like fall over run because it's a negative number. And I look down here and I see I have a lattice point here. See these gray lines are actually intersecting with the actual line. That's a lattice point. So we can fall 1, 2, 3, 4. Okay. So my fall is 4 minus 4. And then my run is just 1. Right? I run to the right. 1, 1. Okay. And so my slope would be -4 over 1, or just -4. And we'll write that here. The slope m is -4. Okay. And the only other thing we need to create an equation like this is the y-intercept. And the y-intercept is right here. That's the y-intercept right there. And the coordinates of that y-intercept are 0 on the x and 2 on the y, so 0, 2. And the part that we're interested in is the 2. And that's going to be our b value. So y equals mx plus b. We've got them both. We got m is -4 and b is 2. So we can write our equation in the form y equals mx plus b. We're going to write y equals -4 x plus 2. And that's it. So we'll put that in a box. Moving on to number 5. Here we're asked to graph a line given the equation. Okay, so this is the same thing we just did, but in reverse. So the most important things are that you understand what M and B are. So it'd be helpful to put a grouping symbol around this -2. Okay, so remember y equals mx plus b. So let's write that above here. We have y equals mx plus b. And you can kind of just, sometimes I tell students to do it like this. There you got your m is -2 and your y-intercept, or b, is +1. Okay. And that means that the y-intercept is located at 0, 1. So you want to plot that point first. So we're going to go find 0, 1. It's right there. And we'll plot that point. And label it. This is the y-intercept. Zero, 1. And now it tells us that the slope is down 2 over 1. Okay, so just remember that m equals -2, which equals -2 over 1. So down 2, right 1. We're going to go down 1, down 2, and then to the right 1. And this will be another point on our line right there. And you could do it again. Down 1, down 2, right 1. There's another point on the line right there. Okay. And you get the idea. So now we can draw on the line by just lining up all these 3 points. And sometimes I like to go up, and I want to make sure I get this line just right. So instead of down 2, right 1, I go up 2, left 1. Up 2, left 1. Up 2, left 1. Up 2, left 1. It just gives me more points to line the ruler up with. So there should be a point there, a point there, a point there. Okay. Looks like it's going to be fine. Now, go, bingo. Okay, so there's the line. And let's put the arrowheads on the end of it. And we always label our lines, okay? So this is y equals -2x plus 1. So we'll label our line here, y equals -2x plus 1. Okay, awesome. So there's nothing to put in a red box because I guess you have to put the whole 4-quadrant Cartesian plane in a red box. Okay. Okay, so that's the end of number 5, and that means we're going to move on to number 6, which is the second page. Okay, so here we are again. Again, I like to do this same thing every time. I'm going to write y equals mx plus b. And in this case, it's y equals mx minus b, right? So b can be negative, but so we'll put plus b. And we just understand that b can be a negative number. And so I see that my slope is 1/5, and that my y-intercept is at -5. Okay, so 0, -5 is the y-intercept. So that's where I go first, 0, -5. And that would be right here. So we'll put a dot there. And we'll label that point as the y-intercept. So this is the y-intercept. 0, -5. And then from there, the slope is telling me to go up 1 unit and to the right 5 units. So up 1 over 5. So here we go. Up 1, to the right 1, 2, 3, 4, 5. Okay, so there's another point on the line. Up 1 over 1, 2, 3, 4, 5. There's another point on the line. And I could go backwards. Down 1 over 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. Okay, that lets me get my ruler just right. Okay. All right, so now we put little arrowheads on the end of that, and we label the line. Y equals 1/5 x minus 5. And that's it. Okay. That is it for number 6. Okay, number 7. What is the slope of the line? And then they give you two coordinate pairs. Okay, so the thing you have to know to compute the slope is the formula for slope. So here's the formula for slope. The slope of a linear equation, slope m, is equal to the change in y over the change in x. And this triangle symbol is the Greek letter delta, which means change in. Okay? Now, practically speaking, what we're going to do to compute that change is we're going to take y2, in other words, the second y value, we'll label them in a second, minus y1, over x2 minus x1. Okay, so now we've got to label our points. So this is x1, y1, x2, y2. And now we can just plug the numbers in. So that's going to be 5 minus 9. Over 7 minus 3. Okay, so 5 minus 9 is negative 4. And 7 minus 3 is 4. So that would reduce down to negative 1. And so to answer the question, we would say slope m equals negative 1. Okay, and that's what we put in the box. Okay, number 8. And here we are again, presented with 2 points, asked to calculate the slope. Let's just recall the formula for slope. Slope m is equal to the rise over the run I'm just trying to show you different ways of saying slope, but then the way we're going to compute that rise and run is y2 minus y1 over x2 minus x1. Okay, so now we got to label our points. 7 is x1, negative 4 is y1, 11 is x2, negative 4 is y2. Okay, so you can come over here and write down y2, which is negative 4, minus y1, so minus negative 4 over x2 minus x1, 11 minus 7. Okay, so this double negative becomes a positive. So it's negative 4 plus 4 is 0. And so we end up with 0. And then 11 minus 7 is 4. And 0 over 4 equals 0. So the slope is 0. Okay, what might that mean? So the slope m equals 0. this can only mean one thing. And you can tell by the duplicate y values here. See how these are the same? This is a flat line passing through -4. So if I was to graph this, very quickly here, you get your y-axis and your x-axis. Okay, -1, -2, -3, -4. Okay, so that's -4 right there. And the graph of the line is flat, perfectly flat, parallel to the x-axis. Okay, so there's the graph of the line, passing right through -4. And the equation of that line would be y equals -4. Okay, and it has no slope. You can think of the slope as an incline or a decline. There's no slope. Okay, and that's number 8. And now we're moving on to number 9. Draw a line representing the rise and a line representing the run. State the slope of the line in the simplest form. Okay, so they just want us to find a couple of lattice points. Here's one. And here's one. Okay. Again, that's you got to know what I'm talking about. It's the intersection of those gray lines in the background. So we're going to find out what the slope is. We know it's a negative slope, right? Because it's downward sloping. But what is it? So we kind of want to form this triangle shape here. And this is down 1, 2, 3. So -3. And then over 1, 2, 3, 4. So this is 4. So yeah, your fall is 3. Okay. And your run is 4. And then want us to state the slope. Okay. So slope m equals -3/4. Yeah, so I mean, this was a multi-part thing, but this is the slope. And then you would have to create this back on this other problem, I forgot to actually put this in a red box on number 8. Okay. And here we are on number 10. We just finished number 9. Draw a line representing the rise and the run, state the slope. Okay, so the same type of question. And what I'm looking for are those lattice points. Here's a lattice point. And the next lattice point I see is here. Okay, so what I'm going to do is say, well, I'm going up to and then over 1, 2, 3, 4, 5, up to over 5. Okay, so this should be 2 and 5. up 2, and then right 5. Okay. Now the slope will be 2/5. So down here we would write slope m equals 2/5. Okay, you put that in the box. And then up here, just this is what you would put in delta. Okay. All right, that was number 10. And now we're moving on to number 11. And these are real quick. Remember, if the x's repeat, it's not a function. So if you're given a table of values and the x's repeat, it's not a function. We're asked to determine whether the graph represents a function. We're going to use the vertical line test. Here's the vertical line test. If I can draw a vertical line like that, and it hits my graph at 2 places, then it is not a function. Okay, so this is down here. We're going to put a box around this. Not a function. Okay, that was number 11. Number 12. Again, I think you're not a function, right? There's many places where I can draw vertical lines. This is not a function. Now, number 13 can be a little tricky. It is actually a function. So these are called asymptotes. These are boundaries. So they don't ever cross here or here. So this has horizontal and vertical asymptotes. And so it's a function. Because my vertical line test would never find the same x value repeated. But here I see that I have what looks a lot like an absolute value, but turned on its side, and it violates the vertical line test. Therefore, it's not a function. And we've just gotten through number 14. And we're on to the last page. Okay, number 15. Again, if the x's repeat, it's not a function. So which one represents a function? Okay, here the x's repeat. So that does not work. Here the x's do not repeat. That works. Here the x's repeat. Not a function. And then here the x's repeat on the 6. Not a function. Therefore, it has to be B. And then the next question, number 16, is asking us which one does not represent a function. So we're looking for the one where the x's do repeat. And I see it here. On C, the x's repeat at 9. So this is the answer. This is not, okay, not a function. Right, that's what they wanted. The rest of them are functions, okay? Okay, on number 17, we're given a function and we're asked to evaluate that function at an integer. So we'll write, the way I like to write this is I like to write if h of x equals 4x plus 4, and then I put a comma, which means then h of 2 equals 4 times 2 plus 4, which equals 8 plus 2, which equals 10. So this is h of 2 equals 10. Okay, so we'll put that in a box. Okay, we're given another h of x equals negative 5x minus 1, and now they want h of negative 4. So here we say if it's the case that h of x equals negative 5x minus 1, then h of negative 4 equals negative 5, open parentheses, negative 4, close parentheses, minus 1. Okay, so negative 5 times negative 4 is 20. So h of negative 4 equals 20 minus 1. So h of negative 4 equals 19. Moving on to number 19. This time we're given a quadratic and we're asked to find f of negative 3. So it's the same process. We say if f of x equals negative x squared plus 2x, then f of negative 3 will equal, be careful here, negative 3 squared, okay, plus 2 times negative 3. Okay, so we have negative 3 squared, that's 9, multiplied by negative 1 gives me negative 9. Minus 6. So now I have f of negative 3 equals negative 15. Okay, and we'll put that in the box. And finally, we're given another quadratic. Negative x squared minus 14, find f of 6. All right, so we say if f of x equals negative x squared minus 14, then f of 6 equals negative, open parentheses, 6, close parentheses, squared, minus 14. Okay, so that's equal to negative 36 minus 14, which is an addition problem. 36, 46, 50. So that would be negative 50. Oops. Started to write negative 15 for a second there. Negative 50. F of negative 6. F of 6 is negative 50. Okay. And we put a box around that. I guess it's time for school, even though it's a Saturday. The bells still ring, and they scare me half to death. Okay, so we're at 52 minutes, and we finished 20 questions. All the work is shown here, and we'll get that uploaded so you can take a look at the key if you need it. Okay, thanks so much for watching. Please make sure to like, subscribe, comment, hit that notification bell so you're always alerted when I release new videos. Thank you.